Hello everyone, welcome to Spinnaker Summit 2022. I'm going to talk about introducing Spinnaker for GCP serverless deployments with Cloud Run and other GCP related enhancements. Yeah, that sounds pretty long title. I didn't mean to summarize everything in the title though. I'm Kiran Godishala from OpsMx, and these are the topics I'm going to cover today. So Cloud Run introduction, and then we'll see Cloud Run resources, how they map to Spinnaker in the implementation. And then we see some Spinnaker enhancements related to the GCP, the Google Cloud provider. And then we see the Cloud Run deployment demo. So let's get into this. So Cloud Run introduction. So what is Cloud Run? It's a managed compute platform from Google Cloud to run the containers. So it's a serverless. So all you need to supply is the container image, and the underlying infrastructure will be taken care. That includes auto scaling. So you need to specify the minimum and max number of container instances needs to be run, and it will take care of auto scaling, scaling it up or down based on the incoming requests. And the deployments are pretty fast. So when you supply, when the container is not so big, the deployment happens in seconds, not even minutes. And it's a pay-per-use, so you need to pay only for the request that was served. You need to pay only for the CPU seconds that were used, and when there are no requests, so you are going to pay nothing. And the use cases, I have listed some. So the Cloud Run deployments can be used for website. So you can expose API endpoints, and you can trigger them and for the asynchronous tasks. So it can be used as a backend for the mobile apps. It can be used as it can receive webhooks upon which you can do some tasks. So, and there can be many more use cases. So this is a very interesting service from Google Cloud Platform. Okay, so Spinnaker is a truly multi-cloud CD tool. And as far as Google is concerned, there are two Google services that were already part of Spinnaker. One is Google Compute Engine, and another is Google App Engine. And Cloud Run will be third. So when we add a new cloud provider to the Spinnaker, we need to consider certain aspects. So what is the account, and what is the load balancer? So the corresponding resources in that new cloud provider, we need to first figure out, and then we map accordingly. So here for Spinnaker, in the Spinnaker terminology, account means the representation of the cloud provider with the credentials and other info that is needed by the Spinnaker in order to perform certain actions in the cloud provider, such as deployments or any other calls needed in that process. So for the Cloud Run, the account is nothing but the GCP project. So we provide the project ID and credentials JSON. So that will be the account. And for the load balancer, so first of all, in the Cloud Run, there are two main components. One is a service and another is a revision. Service provides a unique endpoint to the containers, and it also takes care of the underlying platform scaling up or down based on the incoming requests. And so service is mapped to the load balancer in Spinnaker. And then we have server group. So in Spinnaker, server group means it's a collection of instances of the running software. And the running software in Cloud Run is the containers, and it is represented by revision. So revision contains group of container instances. So you can have multiple revisions within a service, and traffic can be split across those revisions. So Cloud Run revision will be servable. And then you have instance, which is Cloud Run container instance. So these instances will be running in the revision. So these are the mapping, resource mappings we considered for while implementing a new cloud provider in Spinnaker. Okay, now we see some of the Spinnaker enhancements related to GCP. One is a Google Secret Manager, which is implemented as a secret engine now. And others, the remaining three are related to Google Compute Engine Cloud Provider, ADC and Impersonation Support, external Google accounts, autoscaling, enhancements. So we will see briefly what these enhancements are. So Google Secret Manager. So we already have S3 and GCS as the secret engines. So what are these secret engines with respect to Spinnaker? So Spinnaker separates the secrets from the configuration. So in the configuration, you may need to supply certain secrets, but how do we deal with it? So Spinnaker provides an end-to-end secret management by providing these, by implementing these secret engines. So existing or S3 and GCS. So you would add your secrets in, say, S3 bucket, and then refer them in your configuration in certain format. So similarly for Google Secret Manager, you add your secrets in the Google Secret Manager, and then refer in your Spinnaker configuration as shown in this box. So if it is a text, you will write encrypted : Google Secret Manager, and then you supply this exclamation P : and the project number, and then your secret ID, and then secret key. Secret key is optional. So if your entire secret is the text you wanted, then you don't need secret key. If it is a JSON file and within the JSON a certain key value you need, then you use this secret key. And also the Google Secret Manager provides the versioning of the secrets. So if for any reason, if you wanted to use previous versions other than latest, then you can add this v : secret version. So if you don't provide this, the latest version will be considered. Similarly, for using encrypted files for any credentials or any other files needed, then you use this encrypted file and this notation. So this is already implemented. It is recently added to the Spinnaker recent release. Okay, next is ADC and impersonation support. So now we no need to provide credentials JSON if we use ADC. So only application default credentials are sufficient. So the if the Spinnaker is deployed in either any of the Google Cloud platforms like EC2 or GKE, then they provide application default credentials. Of course, there are many ways of providing ADC. So if these ADC are supplied, and if they have necessary permissions to impersonate, then all you need is to supply the impersonated service account and its Google Cloud project. So this impersonated account need not be part of the same account, same project. It can be a different project as well. Still, using the ADC, the Spinnaker will be able to deploy into that project. So Actually, these features were present, but never worked because of some gaps. So now those were fixed. So now you can use a Halyard for supplying these impersonated service account and project, and external Google accounts. So this is basically dynamic account management for Google accounts. So you can supply Google accounts externally. So as of now, there is no other way but to add the accounts through HAL config. So all the accounts will be part of the HAL config. And if at all you want to add or delete any account, so you need to bring down the Spinnaker and then add these, make the modifications and then restart. So with this implementation, you can have the accounts somewhere else, which you can modify, and then after a while Spinnaker will identify those and load them, refresh them. So so you can have the accounts in any external source, and that can be loaded through a plugin. So you need to have a plugin to make Spinnaker know where the accounts are. So we have developed plugins for GCS and Git sources. So that means you can have a file in GCS bucket and use this plugin and supply certain configuration to make Spinnaker know where the account is. Then Spinnaker will load those accounts. If you modify the file with any new accounts or delete the existing accounts, that will be refreshed in the Spinnaker. Similarly with Git source, so you can have a accounts file in a Git repository, and then use the Git plugin, then that will be loaded. And finally, auto scaling enhancements. So auto scaling feature itself was not new, so it was already present, but with a feature flag. So only when the feature flag is enabled, that will appear. That too not at the time of creating the server group or creating the instance group, but after it got created, then you can go and enable auto scaling, supply the min or max number of instances. So now that got changed. So it is now part of the create server group. That means at the time of creating the server group or instance group, you can choose auto scaling, and you can specify that. And now scaling schedules are also added. So that means, let's say for if it is an e-commerce project, and for the Black Friday there will be more sales, so you can add a schedule for so and so dates. Then the minimum number should be this much, so max is these many. So that scaling schedules is added now, and the custom metric utilizations is updated with the more fields. And so previously only few fields were there, now it supports all the fields that are available in the Google Cloud Console. So these are the Spinnaker enhancements related to GCP. And let's see the demo of Cloud Run deployment. Okay, so I have added an account to my Spinnaker, and so it's a Cloud Run account, and I have created a server group, and so this is the server group, and it has a minimum one instance and max. This is for the auto scaling purpose, and it has the instance. And so instance usually doesn't have much significance with Cloud Run, because these are fluctuating based on the request. It will go up or down, and so we cannot completely rely on the instance. So there will be one instance all the time. And then you have a load balancer here. So which is nothing but the service, and this is the service endpoint. We can access this if we have required permissions, we can access this. And if you see, there is only one revision, that is what we are seeing here, one revision having 100% traffic. And let's see the pipeline. So this is a simple pipeline having a deploy stage. And okay, so I forgot to mention, Cloud uses Knative manifest. So if you see here, it's not a Kubernetes manifest, but a Knative manifest. And so which is an open standard, can be used on Kubernetes or any other any other container technology. So main things to identify, to observe here are the image. So right now I configured it to be taken from the parameters. I will show the parameter. And then there is a service account, and this service account should have the required permissions to deploy the service. And so this is basically through manifest we are going to deploy. We are going to deploy into Cloud Run. So these are some of the details. And then, so here I provided a sample image here, so which we are going to use. Cloud Run revisions are immutable. So that means even if you didn't make any change to the image, so it creates a new revision no matter what. Once you create a revision, that's it, you cannot modify that one. So if you make any small change, that will create a new revision. So what I'm going to do now is start this. So I'm going to give the same image and we'll run it. And meanwhile, I will show you this one. So this is the demo project, demo application. So this is the service name. You see here. So demo spin summit. So this will be the cluster, and it creates the load balancer of the service with this name. Okay, so the pipeline executed successfully. So it took less than 20 seconds. And if I refresh this one, yeah, so it created just now. And you see here the traffic is 0%. We can edit the traffic using another stage for editing the edit load balancer stage. So, but we will do that now through the load balancer now. So you have edit load balancer. So if I add, so it recognized that another revision here. So if I make here, say 10% traffic, the allocation must be some to 100. So I'll make it 90. So this will make up 100. Now, if I update, the traffic will be split across these two images according to this percentage. So as of now, you have 100% in the first revision. And now I'm making it 90. And you can see, meanwhile, I'll show you. So this is the YAML for the service, native YAML file. So it shows as of now, this revision has 100% traffic. And we can check the YAML for the revision as well. And now let's see here. Okay, so So that we have edited the traffic here. You should be seeing the traffic split 90 and 10. There you go. So this is a new revision, and we should be seeing that here as well. Yeah. So we even receive 10% of the traffic, and V00 receives 90. So that's the demo. Yeah, that's the demo. Yeah, thank you.